Hi, I'm Adam Stevenson, and I'm a solution architect at SSW. At SSW, we love dependency injection, and we follow the Onion architecture on all of our projects. The Onion architecture makes use of interfaces for behavioural contracts and externalises the infrastructure that implements these interfaces. What's great about this dependency injection-centric architecture is it lets us build maintainable, testable applications because instead of the components of the system all being hardwired together, dependency injection allows for building a system on easily interchangeable building blocks. In this video, I'm going to show 3 strategies for injecting data dependencies into your application, discuss pros and cons of these strategies, and then reveal a great tool that makes it easier to implement the repository and unit of work patterns the way we do it at SSW. To start with, I'm going to show you a basic controller with no dependency injection. What we're doing here is we're just instantiating the DB context and then using it throughout the class. So we can see here we're creating a DB context and then we're using it for queries and we're using it for adding records. Now look, this is bad. We'd never do this at SSW for many reasons. The most important of which is that it's not testable. There's no way to test the index method without it going and querying the database. Let's look at 3 better ways of implementing this same code. In order to make our code testable and more maintainable, we want to be able to inject dependency inject our components into the application. We'll then use these components to query the data without us needing to be aware of how the dependency is being implemented. Now, the first method of dependency injecting our data layer that we're going to have a look at involves us making a business layer, okay, which we'll also refer to as a services layer. What we do is we're going to create an interface in the business interfaces project, and we'll implement the class in the actual business project. We then inject our data context into the business dependency and inject the service into our UI via its interface. Lots of our devs like working this way. They like it because it's easier than the next 2 implementations that we're going to have a look at, and you don't need to create a separate abstraction for the data layer. You can write tests on the service layer method by creating a fake DB context and injecting it. And because the business layer is implementing the entity framework directly, it can take full advantage of the advanced features of the entity framework that usually get hidden behind a repository pattern, like fine-grained lazy loading, eager loading, and the context management features. So let's have a look at it in code. So what we've got is we've got our controller, just up here, where we're taking a product service interface dependency into the constructor of the controller. And now that's exposing just get, add, and update methods. And then these are the methods that we're using inside the controller. So there's our interface for our product service. And if we look at the implementation of that product service, we're putting our data context in there, and our product service is what's actually doing all of the work against the database. Now, if we have a look at this candy store context that's being injected, we can see that it is exposing the available data via entity framework IDB sets. The concern with this method is that your business layer is dependent on the entity framework because the context interface that's being injected is exposing these IDB sets. An example of where this could cause you trouble is that with EF7 coming soon. So one of the breaking changes in upgrading from Entity Framework 6 to Entity Framework 7 is that it doesn't use IDB set. So every business layer class that relies on IDB set will need to be edited and tested. Okay, looking at the next method. The next method we're looking at implements the repository and unit of work patterns. A repository is just a class that looks like it is your data access class, but abstracts away the implementation of the data access. When working with repositories, we use the unit of work to enable us to save changes to different repositories in one transaction. How we implement the repository and unit of work patterns is that we create a repository layer. You can see that here is in green. This consists of a repository interfaces project and a project with the data access implementation that implements the specified repository interfaces. The key point about a repository layer is that when looking at it, you shouldn't be able to tell what the underlying data technologies are. This means that the UI and the business layer have no idea of whether we're using Entity Framework, SQLite, or NoSQL under the covers. Just that you query the repository layer for data and it gets returned in native.NET types. Now then what we're doing is we're taking our database context and we're injecting that into our repository layer. Let's have a look at how this looks in the code. So we can see here we've got our products controller. Our products controller is relying on an interface from here, the iProducts repository. And then we can go and we can have a look at the implementation of this products repository. And we can see that it's exposing methods like add, delete, get. So this is where all of the functionality is coming from. Now there's a fair bit of work involved in implementing the repository and unit of work patterns. So you'll notice that these are relying on generated, so the interfaces and the the repositories themselves are being generated, and they're relying on base classes that come from the data onion. So a key benefit of this pattern is that the UI and business layers are completely decoupled from the implementation of the data access. This allows us to make changes to the data access code without affecting the rest of the application, as well as being able to easily write unit test and manage concerns such as caching, logging, performance tuning, instrumentation, and managing different data sources for the same entity type. It also means changes like upgrading to the latest version of the Entity Framework only ever require updating the repository layer. So we often implement this pattern when we're building simple forms over data applications that are primarily performing CRUD operations. These CRUD applications have very little business logic, and creating a separate anemic service layer that just echoes CRUD operations to the database implementation is wasteful. So how we make it easier to put together this repository and unit of work pattern is using a collection of NuGet packages that we call the SSW data onion. So the repository and unit of work patterns are very helpful when building enterprise applications, but they can be difficult to implement. By simply adding our NuGet packages into the project to the projects in your solution, you can be up and running with the same data access implementation that we use on very large enterprise clients. So the last method that we're going to have a look at combines both of the abstractions that we're using earlier. What we're doing is we're implementing a repository layer, you can see here in green, and we're also implementing a services layer, which is in blue. So what's happening is that we implement the repository layer, and we're actually injecting our repositories, you can see in here, into our services, and then we're injecting the services into the controller. Let's just have a quick look at how that looks in code. So what we've got here is we've got our controller. We're accepting a service, a business service interface into the constructor. Then we have a look at the implementation of that business service interface. You can see that we're injecting our repositories into that business service interface. We look at the implementation of that repository. We can see that our database context is getting injected into there. The benefits of this model are that data logic can be encapsulated into repositories and business logic can be encapsulated into the business services. The pros is that for very large enterprise applications, this provides the best maintainability. The cons is that it's the most amount of work. In smaller projects, this is likely to be over-engineering. So in summary, for apps that aren't just CRUD, they will have rich business logic. The best thing to do is create a service layer. The best thing to do is create a service layer and inject your DB context into it, and then the service layer components into the controller. For simple CRUD apps, use SSW Data Onion to build easily extendable repositories that then will be injected into your controllers. You can still have a services layer, but you won't create a class for each type, only the ones that require more business logic. Now, it's important to note that for projects that don't have databases, for example, ones that just talk to the web API, then they don't need repository and unit of work patterns. So in that case, you'd be better off with the services layer. And then there's the third level. So for true enterprise applications where you'll need a rich business layer and abstractions over your data layer, implement a service layer as well as the repository and unit of work patterns. I hope this has helped outline for you the choices available when implementing your data layer and when working with the Onion architecture. I'm Adam Stevenson. I'd love your feedback on Twitter. I am @ADAMSTEPHENSEN. Thanks for watching.